And Miguel, did you see the dragon tattoo that GPT-4o added to my face?
I did. I did. I heard you took a front picture too, and you asked her for the side profile.
Yeah, it was not a front picture. That's right. It was a front picture. There was not a side picture.
Yeah, very impressive.
Yeah.
Maybe you should get it.
Get a tattoo.
Yeah, why not?
Wonderful. We're going to give about another minute for folks to get in. And if you're just joining, I am looking for 9 volunteers to have their video on for a little bit partway through the presentation so we can see if we can create a Brady Bunch a Brady Bunch visualization from the image, but we'll do that in just a moment. Give about another minute for people to get in. Yes, Aubrey, you're up for it. Fantastic. All right. We're at 4:30. We're going to go ahead and we're going to go and get started. And again, if you're comfortable having, and if you wouldn't mind having some video processing or some image processing, I'd love for you to have your video on, and then I'll be taking a snapshot in just a little bit. I won't be saving it, but we're going to put this through GPT-4o. So if you'd like to have your video on, please do. So I'm Jesse Spencer-Smith, and I'm Chief Data Scientist and Director of the Data Science Institute here at Vanderbilt University. I'm also Associate Dean for the new College of Connected Computing. And this series is a part of what the CCC and the Data Science Institute does to keep you up to date on the latest happenings in generative AI. So Tuesday, we had a really interesting announcement about GPT-4o. And what it was that GPT-4o wasn't changing, but they were opening up a capability that had been there, but had been hidden all along. And at first blush, it doesn't sound like that much of an announcement. It's going to do images. Well, GPT-4 kind of already did images, right? I mean, you would give it a description, and then behind the scenes, what it would do is it would write a prompt and then send it to DALL-E. But it turns out that the capability that was opened up is fundamentally different and is fundamentally new. So what we're going to be talking about today is we're going to be talking about what this technology is, um, and to let you know exactly how this works and what new capabilities this offers, because it is really quite a substantial change in how we've been working with images before. But let me ask you first, quick show of hands, and it could be virtual, it could be your actual hand if you're on video. How many people have used diffusion models to make images? How many people actually have created any images because they're all diffusion models? Okay, so hey, Aubrey, let me ask you, what worked and what didn't work?
So I started using it back when, is it called Midjourney? I was using
Midjourney, yes.
a couple of years ago. I really liked Midjourney. I really liked the process of kind of refining as it went. I've used ChatGPT and Grok and a few others to try image generation. It feels like a little harder to get to where you're going. And I use Magic Media and Canva, which I actually can work with pretty well.
Right.
So far, I tried a little bit on ChatGPT last night and I was impressed. The result did seem better, but I wanted to join this because I'm still not getting quite that Midjourney effect.
Yep, absolutely. Let me ask you, were you able to do text, like long text in it? And can you do like multiple objects? If you do a character, does that character stay the same if you do multiple?
No,
So none of those things happen, right? So no text. Yeah, people change. So if you regenerate, you get something completely different. Let's see, who else is used, and let's just get your experience, and then we'll talk about what's different. Isabel, hello. So
Yeah,
how have
what
you
you're
used it?
describing is a problem I had. I was trying to make an image for a talk with 2 people, and I was like, there's going to be a girl, with glasses, and she's looking at a book, and a boy who's not looking at a book, but he has headphones. Oh my God. Like, I was getting all combinations of these things, never the way I was asking. It was like it could not do a conjunction. Like, it was completely unable to do it.
Yeah, absolutely. Dr. Ya, what has been your experience?
Yeah, thank you so much for hosting these. Similar to everyone else, just mostly the issue with image persistence, being able to maintain the same character.
Yes.
One wonky workaround I found is that if you say like make a 3-panel comic strip and describe it, then it will use the same character for the 3 panels. But if you just wanted to reiterate on the thing that you just generated, it would
Yeah.
not. That was really challenging if you were trying to create a story.
So hacks to sort of get around, but there's a reason why these diffusion models worked like this. And this is it. Because this is a way that diffusion models work. You have a text prompt, which then gets encoded into a semantic space. It's a vector in a semantic space, and it's one shot. You give your description, and then that's the sense that is given to the diffusion model one time, and that guides everything. And that means it's not doing object by object. If you say there's writing on the blackboard, well, okay, there's going to be writing-ish on the blackboard. And if you say, I want 2 people and I want the guy to have glasses and I want the other, that's going to be completely mixed up because it has a concept of glasses, person, male, so these are free floating. You have no specific control, and one part doesn't influence the other, right? So if you put a person in one part of the frame, that doesn't inform what's going to happen in the other part necessarily. So, and the reason what's going on, you have text prompt, then it gets encoded, and what happens is it's latent noise. So it gets moved up to this higher level description of what's going on, and you denoise. Diffusion models start with pure noise. Sometimes they start with images, but noise essentially. And then it learns how to denoise until it lands on a final representation, then it turns it into a picture. But notice that text prompt only gets put in once, and it only gets put in as a vector of meaning, and that's it. That's why things like hands can be so hard, because everything about hands has to be learned here in an image sense, right? So there's no semantics there. It doesn't have knowledge about hands that usually they have 5 fingers. They usually move like this. Hopefully they don't move in odd angles because that would hurt. They shouldn't do that. None of that is there. It's all what images tend to look like. So this is not at all how the new model works at all. So I hate to tell you this, but everything I just told you, throw out, because none of that works anymore. Instead, we have something that looks much more like a transformer. Here's a transformer. Those of you who've been in one of these before will remember transformer. You have your text here. It turns it into tokens. These do get embedded into these high dimensional representations, these vectors. But then what happens is every token, every word or subword influences every other word, right? And it makes sense of this, and it keeps track of order. There's positional encoding. And so there's an attention mechanism and a multi-layer perceptron. So every word influences every other word, and then they get enriched with the meaning. So if I say not and really, well, those get put together and it's not really. Well, that's a totally different meaning than not or really. And so and as a matter of fact, the not really, that by the MLP can be enriched for all the meaning that it has there. And then auto-regressively, so I'll describe what that means. So what happens is it makes a prediction of the next token. That's what's happening with transformers. We see this all the time. We put in text, we watch it generate the answer. What's happening is it actually produces a token, a word. It takes that token, it puts it back into the context, and then reruns everything. So it is actually figuring out everything on the fly, but everything influences everything else. So here's what's different about what GPT-4o released. And actually, this was also released even earlier by Google on March 12th, but they got no credit for that. But what you had was a special GPT-4 is a special model that encodes not just text. Does anybody remember what O stood for when it was first released a year ago? Go ahead and unmute if you remember what O stood for. It was GPT-4o.
Is it Omni?
You were so good. Yes, it was Omni. And it was called Omni because it encoded not just text, but audio and images. It did this. So it was trained not just on words, but also on images and on audio. It was trained on a way where it did encodings for these. And so it learned all of this all at once. So it could actually learn like, oh, hands have 5 fingers. And they tend to look like this. And this is a hand, but this also means stop. And there are other motions with hands that I won't do, but they have, really deep meaning, right? That carry a lot of meaning. Totally unlike under diffusion models, because the full knowledge of the model goes in to inform everything about the images. Everything about the images informs what's happening elsewhere in the model. The text, the audio, we're not going to talk about audio. Text and the image and the audio all influence one another for every step of the way. So that's what's happening. So, Amber, could you share just a little bit? I'll stop sharing for a moment, because you actually use this to solve a problem that you had. Can you describe a little bit of what you did, Amber?
Sure, let me go ahead and pull that up really quick. Yeah, so last year I made this design right here on the top, and that was for a Women in Tech conference. Clearly I had to use a lot of help with Photoshop and things to get the words correct and design how I liked. But I wanted to create a new iteration of this for this year, so I threw that into ChatGPT yesterday and I created the prompt. So I wanted to have it tell me what prompt it would use to have this and create something new. And I added some more features to make it a little bit different. And this is what they gave me. And I liked kind of what they did with it, with adding the buildings in the back of that. And I wanted to kind of have that represent Vanderbilt and Nashville. So I asked it to change that into Vanderbilt and Nashville in some way, some form. And just by it giving it that prompt, it added the Batman building and Vanderbilt's building in the back. So it's getting there. It's a lot faster than it was last year to get to this point. So it's improved a
So
lot.
let's pause for a moment. So here you have images that, you have consistency of characters, of style. And think about, you just said Vanderbilt and Nashville, and it chose 2 buildings that are iconic examples of both. So that's what I mean by when it learns everything together, things in the image inform the words inform what's in the image. Notice the text there. That's actually really good text, right? I mean, it doesn't look wonky. Everything is spelled correctly. That's because the model actually is able to maintain consistency and to know that these are letters and they go in a particular order and they should look like this. The full knowledge of that model is informing that image. So let me pause here. Do you have questions for Amber about what she did and how she did it?
I guess I have a question. If you wanted it to not change, so it's really cool that the text is right and the style is the same and all that. If you wanted to change the buildings and not change the way the lady looks, like the other way, the viewpoint, would it understand that, or is it still impossible?
Well, let me go and stop well, actually, go and answer, then I'm gonna show you another image in just a moment. So go ahead, Amber.
Yeah, so it actually did change it quite a lot. I have some other ones on here, but I would have to kind of shift through them. But just by asking it to change the buildings in particular, it did, and it would flip them as well. So you can ask it to change, I don't like the Batman building right there. Can you move it to the right side of them? And it actually would do that.
But could you say, don't change the woman in the middle?
Yes.
And it will, okay.
Yes, I did that as well.
Okay.
So, and I will show you a kind of a startling example of this, Isabel. I'm going to go ahead and stop your share and restart mine. Thank you so much, Amber, for sharing the work that you did. So here's me. I took a picture of me without my jacket on, and I said, take my picture. I'd taken my picture, but take my picture and make it so I'm looking left. This is entirely generated by GPT-4o. And so it assumed that my hair would be gray in the back, and it is. And here, you can actually tell me how good it is. I would ask you if it gets my jowl right, but I really don't want to know.
Wow.
So
That is, I mean, sorry, I study face recognition. Like I want to make those and then actually study that.
I knew you would. This is stunning. I mean, to be able to do this off of one front image. And keep in
Yeah.
mind, getting everything else right in the image behind it. But let's go one further. Let's say that I want to make a big life change, and give me a dragon tattoo up to my ear, realistic. So now it can do editing here. And this might be one of those tattoos that looks exactly right in 3D if you look on, but then I wonder, well, what would it look like from the front? Now, it's not exactly right. It moved this further over to the front, and notice that it changed other aspects of me. If someone has a tattoo that's going halfway across their face, it's probably they might be a little bit more serious and scary looking. So it actually gave me so you can see it's actually informing, this is where attention is coming in. It's actually informing all aspects of the image, but it takes all the learning about what faces should be and what they look like and presented in different ways. So now you're starting to get an idea of what the power of this is. What questions do you have so far before we move on to onto another part? And then I'm going to tell you just a quick analogy so you can sort of get this in your head. Dr. Ya.
Okay, this is absolutely amazing. The tattoo totally fits you. I fully endorse it. It looks like you're like evil twin from the other dimension or something.
Yes, that's right. It's one of those repeat Star Trek episodes.
I think what's interesting now also, and I think it could always do this, but they weren't allowing it, is that you're actually able
Yeah.
to use a photo of you like that. Because like things have kind of shifted and pivoted to the other extreme. But there
That's
used to be
right.
a lot more concern about using people's images and all that stuff. But now it's like, open open doors to all of that. So that I
Yeah.
just that in and of itself is interesting.
Absolutely. Absolutely. Other questions or comments? All right, then let me share with you, please.
Well, I'm trying to do this now with a novel object, which it's actually it's funny because I gave it an object and I said rotate it, 60 degrees.
Mhm.
And it's an artificial object, and it's like, well, you can give me a 3D model file, or would you like me to simulate what the object would look like? So it's actually pretty smart at it, and now it's trying to do it, and I'm waiting for the results. I
Yeah.
think it's going to do good, but you know, it's
You know what's
interesting that it even understands
it
the
knew.
complexity
Mhm.
of this task because it doesn't know, like
Yeah.
for faces,
Yeah.
it has a model of what, I mean, it can extrapolate from a lot of data, but yeah.
For a lot of learnings. And what's interesting is, every technique to this has been algorithmic in nature. And this is an algorithm entirely of distributions based on learning. This is pure distributional learning that's empowering all of this. There are no rules about a rotation of objects. So it's fascinating. It says, hey, you can give me code for it. I know that I can do it algorithmically, but I don't know what it looks like, but I can simulate it. So this is fascinating to me that we're at the point where you're doing it directly. So let me give you an idea of what the difference is. Stable diffusion is like having like a paint by numbers guide, right? So you take a quick look at the full set of instructions once at the beginning, right? And that's all you got. And you get a blurry outline of what the final picture should be. You know that you're supposed to be painting, a person, outdoors. And so you go through, never referring back to those instructions again, gradually refining it, all the parts, and it's guided by that overall vision, but you don't go back and change your initial plan as you work. You just keep on making it clear until it looks complete, right? That's it.
I
In
wish I
contrast,
could show you what it did. Keep it. Sorry, I'm gonna email. I don't know if.
oh
it
yeah,
would
I might actually
share.
have you share your screen in just a moment. I may
Yeah.
very well
Okay.
do that.
Okay. Because
Yep.
it finished it, and it's
Oh, that's great.
not bad.
So in contrast, a transformer model is like having an art instructor beside you the entire time. So as you paint each part of the mural, that instructor is continuously watching and going back and saying, because you did this over here, and because we know how the shading should work, do the following next. So that's every part of the picture, all the knowledge of the network, and all the wording that you use constantly influencing what comes next. So every brush stroke is influenced by all the previous ones. In addition, it's like having an expert in the field next to you as well. That tree that you're painting right here is a conifer, and the leaves should be pointing upwards slightly in this way because I know that about these particular types of trees. That's the difference between a diffusion model, paint by numbers, get it roughly correct, but you keep on filling in, versus transformer, which everything influences everything else. Yes, Dr. Ya.
I was just thinking that the implications of all this are pretty huge, actually, with regards to being able to generate more data for training and just having
Yes,
this flexibility now. Like this is insane. This is cool.
absolutely. Well, you might recall actually that I showed you some useful graphics, right? At the very first about how to understand diffusion models and the process of diffusion models. Well, in actuality, I didn't create that. So this image, instead, what I did, this one right here, was I had GPT-4o create this. So yes, now we're at the point where you can actually create information and information graphics. GPT-4o can create those because it has all the knowledge about diffusion models. I guided it, and I'll show you a little bit about how I guided it. So here's the prompt that I ended up with. So I want this, and I thought about this a little bit, and I said, here are all the parts that I want to have, and then go ahead and create it for me. And then it created an image, and I thought it was too complex. It was like, that's kind of complex. Plus, I was unsure if it was exactly right. And so I said, is this graphic correct given your knowledge of latent diffusion models? So in addition to being able to generate, it can also encode images so it can absolutely assess images based on that deep knowledge which is stored, right? And so it did an assessment. Yes, this graphic is mostly correct. Mostly correct. And then it went through. So what did it get right? Well, it said, hey, it got the input prompt, latent noise sampling, denoising loop and UNet, classifier-free guidance. This is a part I forgot about. So Abby Petulante is our specialist in diffusion models. And I was like, I think I remember this, but I'm not sure. And then it said, what are the problems? Position of the CFG in flow. It's not really quite in the right place. It needs to be labeled better. The UNet is not in the right place. Summary, overall very good. I give myself good marks, but we could fix it up. And so I said hey, let's simplify, remove that CFG. Please rework. So it gave me a plan, and then I asked it to make the image, and it made the image. And this is what I taught off of. And then actually went a little bit further. I said, hey, can you reformat the image so it'll fit on PowerPoint? Hey, can you add final output image and make it with a transparent background? So it's able to do things like transparencies and, strong control given, other images, make it in the style, but do it a little bit differently. So this is where we are now. Now, keep in mind, this is sort of the worst version of this. So already, you know, it's very sophisticated, but it's the worst version. The other fascinating thing here is it's not using reasoning yet. So imagine a model which is doing reasoning, but is able to reason against images and text, and is perhaps even able to generate images to assist itself in reasoning. Because don't you do that sometimes? Don't you scribble on a pad sometimes to actually help you think through something? The models could do this now. If you have an end-to-end model, which is of this type, it can be generating images for it to use in its own context, especially when it's a reasoning model. If you're unsure what a reasoning model is, go back, watch our previous AI Flash on reasoning models. All right, so I'm gonna pause here, and then we're gonna take questions, and then we're gonna do something fun because it's pretty heavy. So we need to do something fun. So I'm gonna pause here. What questions do you have or comments do you have so far?
How much is this costing them? Oh, I'm so sorry. Go ahead, Aubrey.
Oh, no, go ahead.
Compared to the Fusion model, like how expensive is this for them?
Yeah. So probably really expensive because I've oversimplified here. In addition to after running a whole lot of tokens, because you know images, even in their latent representation, and when I say latent representation, I mean you take the pixel image, you probably do something like a variational autoencoder. If that doesn't make sense, that's okay. You're abstracting the image up to a higher level, more compact representation that represents important aspects of the image, putting that into the transformer. And then when it generates, it needs to decode that image. So that's why when we do it, and we're going to see this in a moment, we're going to see it running, it shows up as a block first with fuzzy sort of like, this is the general plan of where things are going. And then it decodes left to right, top to bottom, just like a paragraph. So that's expensive too. So the variational autoencoders or whatever it's using is expensive, and running the tokens is expensive. Aubrey.
Yeah. So while you were chatting, I uploaded a photo of myself and just said, can you make it look like the background is different and I'm in a high-end home? And it did it. It's crazy close, but my face looks a little different and your image looked to be exactly the same.
Exactly.
So what happened?
That is a really good question, and I don't know.
Because it's like, when I looked at it, I was like, people might
Almost there.
photo of, what's that?
Yeah, but you know, you notice how my picture was influenced by that dragon tattoo. Your photo might have been influenced by your house.
Oh,
You know, and so, and this is where
yeah, because it's like super close. Like if
it's
I
super
if I
close,
saw
but
it from afar, I'd be like, maybe that's me. But I was like, whoa, that's not
did
me.
it put makeup on you?
No, it just changed the face structure just a little bit.
Fascinating.
Very
So, and this is where we have to explore. And Isabel, I certainly hope you do explore this, because what are the facial representations, and how does context change those? Now you can try, Aubrey, in the next one, you can say, keep me exactly the same.
what I
Because
did
it
for the
knows what
second
you
prompt,
are.
yeah, what I did for the second, I said, can you make my face closer to the reference image? And then
Yes.
it kind of then I looked very different. So maybe in
Yeah.
the first one I need to say, keep my
Yeah.
face exactly the same.
Yes.
Yeah.
So here's the other thing that happens, because all of this is sitting in context, and all of context is influencing everything else. It gets really squirrely, because everything is, and so we notice this. You can't go very far in getting new versions, because the bad versions are influencing you just like the good versions. So it has a limit of object binding. And Isabel, I thought you might be really interested. Object binding of about 10 to 20 objects, where characteristics and properties of images can be bound to about 10 to 20 different things. Well, that's 10 to 20 different things across all the images that are generated. So there's a limit. So you have to think about how to do that. So actually, I went through many iterations of mine and finally said, hey, just come up with a really good prompt for me, and I'm going to start over. And that's how I got to that really good image. Shay.
This is really cool. I wonder, you mentioned about the reasoning model just now. I wonder how, so under GPT-4o, how reasoning model and this diffusion model are integrated together.
Yeah, this is, I have a feeling, because remember, GPT-4 has been around for a long time, right? It was trained on all of this together. So at the very first, when they did the huge training of this thing's well over 1 trillion parameters, and they trained it on a huge tokenization dictionary, right? And so it was enormously expensive to train. That's why I bet we're not going to see a reasoning version of GPT-4o. I think it's too expensive to retrain. So, are we going to see a reasoning model from them that's multimodal? Maybe, but probably not right away because it's going to be expensive to do. Others may get there first. We have Qwen that just released an Omni model. And it's much smaller. Theirs is 32 billion parameter. They might get to a reasoning model first before OpenAI does. And we just don't know how much better does it get if it can reason. I'm thinking a lot better because I had the full description of what I wanted. It could generate the image and say, and then assess itself on its own and say, no, I need to redo. Other questions and comments? Then shall we try to do something fun? I would like for us to recreate and just we'll see how well it does. We're going to be pushing the limit to remember that 10 to 20 of the object binding. Let's see if it can actually do object binding against 9 faces. And so, and again, if you're unsure what the Brady Bunch is, so this was the Brady Bunch. 2 families coming together. The mother and father fell in love and they got married and they had to blend the family. And here's the opening sequence. Extremely cheesy, extremely fun. I grew up with this. I loved this. But let's go and see if we can't take a screenshot of those who are willing to have their screen, of their camera on. And what we're going to do is we're going to get this to ChatGPT. We're going to say, hey, turn this into the Brady Bunch opening sequence with the squares, with people looking at one another. Now, I want you to be looking straight on, but we're going to see if it can rotate all of our faces in ways and maybe give us expressions. Are we game? Okay, then I'm going to have to get to a different view here. Go ahead and, kind of resize this a bit so I can get it to be 9 by 9. And I'm going to take those people at the top. If I don't get you, then I'll see if I can get you another time, okay? So my apologies if I don't get you right away. All right, I've got to do my screen capture. All right, okay, Aubrey, we'll give you a chance. Okay, we ready? All right, here we go. All right, now I've grabbed everybody. I think I did that the right way. Let's go ahead and go to ChatGPT. All right, I'm going to see if I can find this image that I just created. Let's see, is it 5.0? Did I get this today? I always have such trouble with this. Screenshot, that's from earlier in the morning. This is from, okay. I'm going to try this one more time. So it's going to be Alt Control. So it's not Shift, it's got to be. It's always a challenge. I might even have to get guidance from you all. So I've done that. Okay, so did that save it? Oh, there we go. Oh, good, good. Oh, here it is. It just didn't populate it. Okay. So what we're going to do is we're going to grab this one. So this is who we got. And I'm going to say, please turn this into a Brady Bunch opening sequence like image with people looking at each other.
Jesse, are you intending to share your screen?
Yes, I am.
I am not able to see it, but it might just be me.
That's probably because of a slight technical issue of me being an idiot. There we go. Here we go. Okay, so I've uploaded this. Please turn this into a Brady Bunch opening sequence like image with people looking at each other. Keep everyone's face, identity, but shift their gaze and expressions. All right. Any other changes? All right, we're going to give it. So this is who we got. So it's going to, you'll notice a couple of things. We're just going to have to give it time, and we'll take more questions as it's working, but we'll watch it as it's working. Notice that it is, first it's running, so it's actually doing some of the work here. Then you're going to notice when it's done with generating the latent representation, it's going to give you this. It's done, the transformer's done its work, but now the decoder has to do its work. So it's still a lot of work, and you'll notice that it'll fill in from left to right, top to bottom. And while we're waiting, what questions or comments do people have? What else have people tried?
Hey, Jesse, thank you as always for this. Amazing. I have a quick question for you. I feel like a lot of these tools up until now had a policy restriction against doing things with real human faces, right? What do you
Yes.
think changed that just because they wanted to show how cool it is? So they just kind of lifted that policy restriction.
DeepSeek. I think DeepSeek happened.
Can you say
I
more
think
about that?
DeepSeek released by a Chinese company with no restrictions whatsoever. And so they
Wow.
realized that they wanted to maintain an edge. And so what they did was they just said, well, we're moving the goalposts. I think that's also what happened with GPT-4o and releasing this capability. I don't think they would have released this capability if DeepSeek hadn't happened. I also don't think they would have done it if Google had not released on March 12th their end-to-end multimodal model as well. So here we go. So Aubrey and Amber, oh, it changed your identity, Amber. So it changed you. It changed me. It aged me. Hey, man. I'm almost 60, but I'm not that old. Sharo, it changed you as well. So here I think we're seeing it's reaching the limits of what it can do with the binding. So it's ish, right? It's close, but these are a lot of among I love your expression. That's hilarious.
It did an amazing job with the names. I mean, let's give it that. The
Mhm.
lettering has always been so absurdly not good. So I've been
Exactly.
impressed with that.
And it's and that because you have really good context for that, right? You know what an A is supposed to look like sans serif, right? It probably has even learned the different typefaces. So it is likely that that binding is going to improve, not for GPT-4o. For GPT-4o, it's going to be getting better sort of at the edges, and with consistency, but there's only going to be so much that can happen because the attention mechanism, everything that was used to train GPT-4 is fixed. That model is what it is right now. But for other additional training and for giving it more background and for maybe even giving it more training on what images mean and so forth, that's going to work. Something else that is important to keep in mind, and here maybe I'll copy this and I'll see if I can share this in well, I promise not to share this, but so here you go. This is what it looks like. If y'all want to. I'm going to take this down, but thank you all for being game for this. One other aspect that I'd like to mention, and then we're going to open up for general questions and comments, is in-context learning. So in-context learning is the ability of the model to actually learn things on the fly. Because the model is encoding images and audio, it can learn from series of images. So we know in-context learning is extraordinarily powerful. It can learn new ways of solving problems if you give it enough examples. And this is an area which is absolutely not explored because this is not a property of the model itself. This is an emergent property of the activation states of the model. So in-context learning is really, being actively explored. But now that we have access to a powerful model with a long context window that encodes images, we can do really interesting things to see about how well it can learn off of images, one after the other. Keep in mind, we're not training the model with this. Once you're at the end of that context length, that's gone, but that's a whole new area. So end-to-end omni model, more fully revealed now. Ability in the future, so we can explore everything we can do with that, all the cool stuff we saw. Plus, in the future, looking and exploring reasoning models and reasoning against not just text, but images and audio. And third, exploring in-context learning. These are all new possibilities, research areas for us all to go after as your ability and desire dictates. So let me ask this. Let's see. Do we still have? Let's see. I think we might have lost. Let me open this up for comments, questions. What questions do you have about these new models and these new capabilities? And Isabel, if you're there, you might have had to step off. I'd love for you to share if you're here. Dr. Ya.
Do Midjourney and all these other providers now have to pivot to this new model now to stay competitive? I mean,
Yeah.
it's interesting that it's the transformer that is able to accomplish this. And
Yeah.
just with transformers in general, I'm curious about your opinion, whether transformers really are it and the way we're going to get to, I don't know, AGI or whatever. Because like Jan LeCun, who is the chief data scientist
Oh, I
at
know. Yes.
he just is not a fan of transformers, like at all. But I mean, it seemed to solve this problem. So I'm curious what your opinion is
Yeah.
about transformers versus something else
Yeah.
out there that we're not investing enough in.
Yeah. So, so first of all, will it get to AGI? No, never. But that's only because we're really good at redefining AGI. It's a very uncomfortable thing to say that we've achieved AGI. So we have passed all previous measures of AGI already. And then we keep on moving the goalposts. We say, well, actually, so yeah, so no, no fear of that because we're just going to keep on changing. But really, it's not. Are transfers going to be it? I would say, I mean, there's getting to be fewer and fewer things that we consider to be important for us to be able to do that we can't do with transformers. It is not a biologically plausible way, but that's okay. Jan LeCun might be right, but he's not right in that these are inherently limited, right? Because these are powerful distribution learners. Yes, there's some interesting kind of limitations because it's autoregressive, but we can do an awful lot that's useful and we can learn a great deal from them. So must we move to another architecture in order to do those things? No. Can we do a more efficient architectures? Absolutely. I hope we come up with new architectures, but man, this has been around since 2017. And it's been the backbone in one version or another of every major advance. So I'm not saying that that we're not, but there's probably a lot of gas left in this tank, especially with the multimodal learning, especially with reasoning. So I welcome future, but I think we can do a lot more with what we have. And was there a second part of the question? I don't remember now.
No, that was it.
Okay.
Thank you so much.
But absolutely. Now catching up, it's going to be very difficult to come up with a good multimodal model that's huge. Because it's expensive to train, and you have to have that very large space for the tokenization scheme. But think about all that. So Aubrey, were you the ones who used? No, who was it that was using Canvas or Canva? So we use Canva, but think about this: if this can generate and format text and do formats and actually take an example of something that you had before and then redo it with updated text or in a different style, this is going to be challenging for a lot of different graphics programs. Graphic designers are going to have to sort of, figure out how to use this and to leverage this to broaden their work, it's going to be hugely challenging. Jennifer.
Maybe it's for after the call because I know I'm putting you on the spot. But do you have any good papers or references on object?
A good paper or references on these types of multimodal models? Good
Object
question.
binding specifically, like the
Object binding.
overall strategy.
Isabel, are you
Yeah.
still here? Because yes, I'm a cognitive psychology. Yes, I did work in this, but I did work in this like 15 years ago. If you will drop me an email, then I'll put out the word and we'll see if we can't get some good references on this.
Awesome, thanks.
Yeah, but actually Isabel Gautier, who was on here before, she's not a bad reference. She's written some pretty foundational papers in that broad area. All right, other questions or comments from folks?
Well, back to the reasoning model, we know that reinforcement learning is a major tool to improve
Yes.
Performance of the reasonings.
Yeah.
I wonder, do you think RL can also help this diffusion model in the future?
Oh, the diffusion model itself, I'm thinking, so think about Sora, right? So Sora is a diffusion model, but it has a transformer in the middle of it. So but both of these are kind of like combination transformer and diffusion. This is much more transformer. This is like all transformer except for the beginning step where you're tokenizing and the end step, the end when you're on encoding. Those are a little bit transformer, like they're more like latent is what they are. But
Yeah.
Sora is kind of like all diffusion, but with a transformer in the middle. And it was able to do really interesting things like learn physics, learn native physics, like what happens with hair. I can't do it. My hair's not but if you have longer hair and you do this, right, it flips up or vibrates. Extraordinarily difficult to model with using a physics image, almost impossible. It's just really complex. But the Sora model does it very naturally. Why? Because it learned through the training of what that should be. So it learned natively the physics by being trained on video. So can RL be used with diffusion models? Maybe if it's like Sora and there's a transformer model in the middle, would it allow it to do this? No. Because here what you're doing is you have joint training at the same time in the same embedding space of image and audio and text. So that's that same semantic space all being populated by all these things all at once. And that's going to be, I think that's going to be impossible to beat with another architecture that doesn't do that. But I could be wrong.
We'll see. I can also imagine that the computation time is huge for training these
Yes.
images.
I absolutely agree, because this is not like using, I mean, I think it is enormous. I'll be interested in seeing what small models can do, truly multimodal end-to-end with multimodal tokenization schemes, small models might be able to do. I think we're just beginning this journey, and I think we have a lot of learning and experimentation to do.
Fun.
All right, folks, we're gonna end there unless some people have additional questions. I'll hang around here in just a little bit. I thank you for your time. I'm glad you joined us for our AI Flash. And and let me share one other final image here. I need a slide, so make me a slide for our AI Fridays. Here, let me go ahead and share my screen. I needed a slide make me a slide for our AI Fridays, because I want to invite you all to our AI Fridays. So, hey, if you have anybody with outside questions, about AI and teaching, research, or other, you can meet with their data science team. So you can read it here. I wanted an image for that, but I said critically, what questions do you have before making me an image? And it said, hey, tone and style. What do you want the text on the slide to be? Should it have Vanderbilt branding? What's the format? Any do's or don'ts. I love the format. Hey, do you want a 16:9 slide? So once you have your preferences, I'll create it for you. I told it my preferences, and here's my final slide for y'all. AI Fridays. Friendly robot in the middle, drop-in help for teaching, research, and more. Please drop by. Open office hours every Friday, 10 to 12 here at the Data Science Institute. We hope to see you there. See y'all soon.
Thank you guys so much for this amazing just educational service you offer.
Absolutely.
Thank you.
Absolutely. Thank you.